All right, today we're going to be doing Law of Cosines. And what is Law of Cosines? Well, we know how to handle right triangles. We did that yesterday. All right, SOHCAHTOA. But what about when there's no, what about triangles? Um, what about when a triangle doesn't have a 90-degree angle? That's where Law of Cosines comes in. We're going to also do another type of law also. I think that's tomorrow. Maybe, whatever. Starting with Law of Cosines though. All right, so what is the Law of Cosines? Law of Cosines is if I'm given some triangle, right, A, B, C, no right triangle in there. Yeah. Remember that your sides are, so capital letters are the angles, right? And then lowercase letters are the sides. So side A would be opposite angle A, side B will be opposite angle B, and then side C will be opposite angle C. Well, it turns out that you can find any of these sides based on the angle opposite it and the two sides that are, it's like a side angle side given, right? So for, let's say for angle A, right? It works for any of the angles. I'm just going to give you one formula though, and then you can see that it applies to any of these angles. All right, so side A squared is equal to the other two sides, so B squared plus C squared, so this side squared plus this side squared, minus 2 times B times C times the cosine of the angle A. So that's what you need to memorize and use. Yeah. So let's do an example. Let's do one in triangle ABC. You're given that B is 5, C is 7, and the measure of angle A is 39 degrees. So 39. Did a little swoopy. Let's find side A and round to 2 decimal places. All right, so I'm going to draw a picture first. It helps me. I don't know about you, but I'm a visual person. So if I go, this is A, B, C. Side B is opposite angle B, so that's a 5. Side C is opposite angle C, so 7 is over there. And then the measure of angle A is 39 degrees, and then this is side A. All right, so your A squared would be B squared plus C squared minus 2 times B times C times the cosine of 39 degrees. Yeah. Now I could certainly put this in my calculator and I'll get a really long decimal answer, but what I recommend that you do is go, oh, well that means A is going to equal the square root of that whole thing, and you can enter in the whole thing into your calculator all at once and then round, because what you don't want to do is get a decimal for this guy and then and write it and then take the square root of a rounded answer, right? You don't want to round until the end. So I'm going to be putting in my calculator the square root of 5 squared plus 7 squared plus 2 times 5 times 7 times the cosine of 39 degrees. It's saying cosine of 39 degrees, and so you do need to make sure you're in degree mode, and I am. All right. So I've got square root of, notice it starts a parenthesis. Okay, good. 5 squared plus 7 squared minus 2 times 5 times 7 times cosine of 39. And I was in degree mode, so I'm golden. And I get that A is approximately 4.5 427, and I said round to 2 decimal places. So the 7 says round it up. So A, I'm going to say is 4.43. Easy peasy lemon squeezy, right? All right, try one on your own. Try one on your own and see if you get it. In triangle ABC, we've got side A is 7, side C is 9, and the measure of angle B is 34 degrees. I want you to find side B, and again, round to 2 decimal places. So pause your video right now. Try it on your own. See if you can get it. Pause it, and I'll be here. All right, so in triangle ABC, you should have said that was 7 and 9 and 34 degrees. All right, and now it's a B, here's B. B squared is equal to A squared plus C squared minus 2AC times the cosine of angle B. Law of cosines works for any of them, right? So we've got B squared will be 7 squared plus 9 squared minus 2 times 7 times 9 times the cosine of 34 degrees. And remember, you'll do the square root of that whole thing. And you should have gotten 5.053, and rounding to 2 decimal places, 5.05 was my answer. All right. We can also use law of cosine. So these guys were what I call sassy triangles because you were given a side, angle, side. Side, angle, side. The angle, the two sides with the angle included in the middle there. Side, angle, side. So a sass, side, angle, side triangle. I call it sassy. The other time that you're going to use law of cosines is if they give you a snaky triangle. That's what I call it anyway. It's a side, side, side triangle. And you'll use law of cosines for that type too. So example 3 is going to be a snaky triangle. So in triangle XYZ, side X is 3, side Y is 7, side Z is 9, and we're going to find the measure of angle Z. And we'll round to 2 decimal places too. So why do I call this snaky? Because if this is X, Y, and Z as my angles, side X would be 3, side Y would be 7, side Z will be 9. And you see that they gave you a side, side, side triangle. Snaky. That's what I call it, snaky. All right. But it works the same way. You should definitely find, like when they give you these, you should be definitely finding the biggest angle first. And then this, they wanted us to find angle Z. So notice 9 is the biggest of the 3 sides. And so Z really is the biggest side. So we're good. The angle we're finding is correlating to the biggest side. All right, so that means we'd have Z squared is equal to X squared plus Y squared minus 2 times X times Y times the cosine of angle Z. But that's the one we're trying to solve for now, right? All right, so watch your order of operations. You need to, like all of these guys are being multiplied times the cosine of Z value, right? All of these guys. I know you're subtracting it, but all of these guys are being multiplied. These guys are being added. So you'll subtract the 3 squared from both sides. You'll subtract the 7 squared from both sides of the equation. Does that make sense? But you don't go adding this number because it's being multiplied times cosine, if that makes sense. Maybe we should clean it up first. Maybe I should have written, okay, so forget all of this for a minute. It would be 81 is equal to 9 plus 49 minus, what is that, 42 times cosine of z. Yeah, so now you can subtract the 9, subtract 49 from both sides of the equation so that you would end up with what is that? You're subtracting 58. So 23, yep, is equal to negative 42 times cosine of z. All right, now you divide both sides by the negative 42. So that you get a negative 23 over 42 is equal to cosine of z. Just because it's typical for us, we don't ever leave a negative down in the denominator. Either stick it up top or put it in front of the fraction bar. Either way. And then to solve for cosine, or to solve for z, you need to take the inverse cosine of both sides. So inverse cosine of negative 23 over 42 is equal to angle z. And put that in there. Inverse cosine, I'm still in degree mode, of negative 23 divided by 42. And I get that angle z, measure of angle z, is about 123.203. So 2 decimal places, I would put 20. Don't forget your degree symbol. Otherwise, you're in radians, right? Okay. Try one on your own. See if it made sense. And triangle ABC. Side A is 5, side B is 6, and side C is 8. And I want you to find the measure of angle C. All right, pause the video right here. Try it on your own. See if you get it. All right, hopefully you paused it, you tried it. A would be 5, B is 6, C is 8. So now you're going to have a C squared is equal to A squared plus B squared minus 2 times A times B times the cosine of angle C. And that's a what? 64 equals 25 plus 36 minus 60 times cosine of C. Subtracting that, that's what? 61. Right, so when you subtract 61, you'll get a 3 is equal to negative 60 times cosine of C, dividing by negative 60, and taking the inverse cosine of that guy, which does simplify. That's a negative 1 over 20. And then you should have gotten that the measure of angle C rounded to 2 decimal places is 92.87 degrees. All right. Last one. Because sometimes you'll come across something weird. So better that I show it to you. In triangle GON, well, that's weird. Gone. Because you're gone. Gone. There's some song. Whatever. All right. Little g is 8. Little o is 3. And little n is 12. Let's find the measure of angle n. All right. So I'm going to draw a picture. G, O, N. And little g is 8, and little o is 3, and little n is 12. And we want to find this guy. So it's the side opposite it. 12 squared is equal to the other guy's squared. So 8 squared plus 3 squared minus 2 times 8 times 3 times the cosine of angle n. All right, so what is that? 144 is equal to 64 plus 9 minus, is that 48 times cosine of n? 64 and 9 would be 73. So I'm going to subtract 73 from 144 and get 71 is equal to negative 48 times the cosine of n. Dividing both sides by negative 48, we'll get that cosine of n is equal to negative 71 over 48. And doing the inverse cosine of that guy is what will give me angle n. Yeah? All right, let's put it in our calculator. All right, so I've got inverse cosine of negative 71 divided by 48. What? Domain error? What? Did I hit something wrong? Nope, I did not. I did not hit something wrong. If you look at, do you remember that your cosine of any angle has to be between 1 and negative 1, right? Always. Cosine of any angle is always between 1 and negative 1. And so 71 over 48, let's look, 71 divided by 48, oops, clear, 71 divided by 48. Dang it, come on now. 71 divided by 48. 3 times the charm. Here we go. Boom. 1.479. So you were trying to take you were trying to find the angle whose cosine value is a negative 1.48, right? Not possible, because the smallest it can be is a negative 1, right? And so if you get a domain error, your answer is no triangle exists. No triangle will exist with sides 3, 8, and 12. It's not going to happen. All righty. That's it for me. That's it for section 2. Come see me in office hours if you have questions. Yes. All right. You guys have a fantabulous day. Bye.